Here is the application of Ampere's law. First one is infinite long straight line. Infinite long straight line. Application of Ampere's law. Infinite long straight line. That means when we consider a coordinate system like this, x-axis, y-axis and z-axis. Now I am placing an infinite line along the z-axis. Just place an infinite line along the z-axis and it will creates a field around it like this. The field will be creates around it. Now consider the field motion will be in a phi direction. The field will be exist in a phi direction. Just I am assuming as the field will be exist in the a phi direction. Then h bar can be written as, h bar is a vector. So we know that the basic existence of vector can be represented as a magnitude, and h bar can be represented as is magnitude and as well as a direction. So I'm assuming its magnitude is h phi and the direction already represented here. I'm assumed that means it will be flows in phi direction. So it is a phi bar. It is one of the existence. And then we have already in our previous topic we have already represented that in case of cylindrical coordinate system, cylindrical coordinate system, dl bar equal to dr ar bar plus r d phi a phi bar plus dz az bar. Now I am making here h bar dot dl bar, that is equal to this one, h bar h phi dot a phi bar dot dl bar is this dr ar bar plus r d phi a phi bar plus dz az bar. Now look at here, a phi dot ar 0, a phi dot a phi 1. So here h phi into a phi dot a phi 1. So the remaining term is here r d phi. A phi dot is at 0 again. Then it will gives us h bar dot dl bar equal to h phi r d phi. Now here in this topic we are deriving the expression for infinite line by depending on Ampere Circuital Law. In this topic especially applications of Ampere Circuital Law. That means the field intensity, the infinite line field intensity is calculated by using Ampere Circuital Law. So in our previous discussion we have already derived Ampere Circuital Law, that is according to Ampere's Circuital Law. According to Ampere Circuital Law, we have that is simply line of h bar dot dl bar equal to I enclosed. This is the statement of Ampere Circuital Law. We have already proved in our previous topic. So now here is h bar dot dl bar. Look at here, h bar dot dl bar, h bar. Now I am substituting this value here. So line integral of h bar dot dl bar means h phi r d phi is equal to I enclosed. Again look at here, what is the differential term that will be existed here, that is d phi. So we have to apply limits as for phi. We know that for phi the limits are 0 to 2 pi. These are the limits for phi. So I am applying limits. That is here integral of 0 to 2 pi h phi r d phi equal to I enclosed. Now I am letting constant term to this side. So h phi into r into integral of 0 to 2 pi d phi equal to I enclosed. Now I am applying integration for this. So h phi into r into, by applying integration, d phi will becomes phi, and the limits are 0 to 2 pi equal to I enclosed. Then h phi into r, by substituting upper limit, it is 2 pi minus lower 0, that is I enclosed. That is h phi into r into 2 pi equal to I enclosed. Then h phi equal to I enclosed by 2 pi r. I enclosed by, here is 2 pi r, I am letting to this side. I enclosed by 2 pi r. It is the expression for h phi, that is magnitude only. Magnitude only. Here, look at here. Actually, h bar is h phi into a phi bar. So, finally I am writing, finally h bar is equal to h phi into a phi bar. Look at here. We have already assumed initially. Initially we have assumed here. Then h bar equal to h phi is this. That is I enclosed by 2 pi r into a phi bar. It is magnetic field intensity for infinite line. Infinite line. H bar for infinite line. It is the expression for h bar for infinite line by using Ampere's law. By using Ampere's law.